Hi to all. Today's topic is magnetic dipole moment of a revolving electron. When one electron is revolving, right? Electron revolves around the nucleus in the atom. Inside the atom, electrons revolves in particular orbits around the nucleus. Now, that electron magnetic moment I am going to derive. We know that current carrying coil behaves like a magnet. When electron moves around the orbit, then it also generates the current when it completes one rotation or one revolution. Then the current, due to that current in orbit also electron is moving. Due to the motion of the electron, some current will generate. Due to the current here, it can produce the magnetic moment. Now let us see here. I am going to derive the formula for the magnetic moment of revolving electron. Previously we derived the magnetic moment of current carrying coil. Now let us see here. An electron is moving in a particular orbit. Okay, consider an electron revolving in circular path in certain orbit, okay, whose radius is small r with velocity v. Okay, now the charge of electron is, we know, q is equal to e, the radius of the orbit is small r. Now first we have to find out the current in the orbit. Current in orbit. How to find out the current in orbit? What is the formula for the current? The current formula is charge by time. Okay, how much charge flowing at here? E. How much time? Then to produce the current flows only in closed circuit. When the electron starts at here, again it comes to the same position, then we say that it is completed one revolution. Then at that moment some current will be produced. Further, the time taken is taken as time period. Capital T is the time period. Okay, time period. Now what is time period? Let us see what is time period in this. The time period is where the time period is time period, right? What is time period here? T. Time period, how we will write the formula for the time period? Time period means what? Time taken to complete one revolution. Okay, after one revolution it will become closed. Then in the closed path only current will flows. That's why we write the time period. Here time is time period. The current is equal to charge by time. Time period we write as distance by speed. Time is the distance by speed. Then how to write the distance? How much distance it can cover in one revolution? That is 2 pi r. Its speed is what? It is moving with speed v, right? Then the 2 pi r by v. Distance covered in time period, one revolution, circle length. Okay, the circle length is 2 pi r. By speed is v. Okay, this we substitute in above equation. Then current formula we will get is I is equal to E by T. T is what? 2 pi r by V. And this will goes to numerator. Then we will get I is equal to EV by 2 pi r we will get. This is the current formula. Equation 1 let us take. Okay. Now let us see. I am going to derive the formula for what? Magnetic dipole moment. We know already, for example, if it is a current carrying coil, okay, magnetic moment of current loop is what? Or the current coil? Magnetic dipole moment of current carrying coil. What is that? Okay, current carrying coil. If you want the magnetic dipole moment of current carrying coil, okay, and its formula is, what is that? Magnetic moment formula is NIA, right? This is a coil with N turns and the current in this is I and the area of this coil is A. Then the magnetic moment formula is NIA. But here we want the magnetic moment of revolving electron, right? Revolving electron. The same formula we have to use here. That formula is NIA but here this is a revolving electron. Okay, only one turn will be there. That's why we take n as 1. N is 1, then this formula will become n is equal to 1. Okay, 1 orbit, okay, 1 turn, and current is I. Area of this orbit is pi r square, we write. Okay, now the magnetic moment is equal to I, we write from equation 1, then EV by 2 pi r into I into A is there, right? I we wrote here, pi r square is remaining, we can write like that. Okay, area is pi r square, n is equal to 1. Here the since the two things we wrote in this, one is n is 1 and area we wrote as pi r square, right? Okay, and this r square will cancel and pi will cancel. The remaining we will get as EV, here 1 r will remains, by 2. This is the magnetic moment. Magnetic moment of revolving electron formula is EVR by 2. EVR by 2. This is equation 2, let us consider. Okay, and here we are writing I formula in this equation at here, EV by 2 pi r, that is from equation 1. And here we got the magnetic moment formula. I will simplify this one. Here what is E, what is V, what is R, you know, that is E is the charge of electron, V is the speed of electron, and R is the radius of the orbit in which the electron is revolving. And now I want the magnetic moment in terms of angular moment. For that, what we have to do? Okay, I will change this one like this. This one I will do like this. EVR by 2. Now I multiply with M and divide with M. Then this we write, I will modify this one. E by 2M into the remaining is MVR. MVR we write. You know already that MVR is the formula for angular momentum, right? E by 2M into capital L. What is capital L in this? Here we are writing the MVR with capital L. Okay, capital L indicates MVR. It is angular momentum. Angular momentum of revolving electron. Revolving electron. Okay, that is in terms of angular momentum. Okay, in this way you can write the terms also if you want. E means charge of electron, right? Charge of electron. What is M? M is the mass of electron. Mass of electron. This is the formula for the magnetic moment. Okay, the one is in terms of charge of electron, speed of electron, radius of orbit, and the other is in terms of electron charge and mass and angular momentum, right? Take the screenshot and note every point, and this is most important topic. Take the screenshot and note it. And now I am going to continue. Okay, magnetic moment formula here we got. I am going to write the magnetic moment formula in another format. For that, one thing I will do it here. But according to Bohr's postulate, I am going to rub this total. Okay, the continuation of that one. According to Bohr postulates, Bohr's second postulate. Do you know the Bohr's postulates? Bohr's orbital model, right? That is, according to that, angular momentum is L is equal to nh by 2 pi. This is the formula, nh by 2 pi, where n is the principal quantum number. This we can substitute in above equation. Okay, this is equation 4, and 4 is substituted in equation 4 is substituted in equation 3. Now what you will get? The m formula, E by 2m into L we write. L is nh by 2 pi according to what? According to Bohr's postulate. Okay, and this we can simplify here. We got these all values, and after that you can substitute. But we know what is n here. N is the principal quantum number or orbit number. N value may be 1, 2, 3 and so on. What is h? H is the Planck's constant. Planck's constant. E charge of electron. M what? M is the mass of electron. That we know already. If you substitute the Ni is 1, you will get the minimum value of magnetic moment. Okay, the minimum value of magnetic moment, N value may be 1, 2, 3 like this. In that, 1 is the first orbit. First orbit is the minimum. N is the minimum value. When you substitute the minimum value, minimum magnetic moment, you will get the minimum value of magnetic moment. The minimum value of magnetic moment. The minimum value of magnetic moment of revolving electron. The minimum value of magnetic moment of revolving electron is called as Bohr magneton. What we call it is Bohr magneton. Bohr magneton. Bohr magneton. Which is called Bohr magneton? The minimum value of magnetic moment. How we will get the minimum value of magnetic moment? N is equal to 1, you substitute. Electron charge you substitute as 1.9 to the power of minus 6. And next, Planck's constant 6.625 into 10 to the power of minus 34 into 10 to the power of minus 34 joule second. And the next what terms are there? Mass of electron 9.1 10 to the power of minus 31 kg. These all values you substitute in the above equation. Then when we substitute it, we will get the m value, right? What you will get the m value? That I will get the m value as like this. I am going to rub this also. Right, now you substitute all values in this. M is equal to 1.6 into 10 to the power of minus 19 by 2 into 9.1 into 10 to the power of minus 31 into 1 into 6.625 into 10 to the power of minus 34 by 2 into pi value is 3.14. After this you substitute. Here M is what? Bohr magneton. Bohr magneton. Okay, after simplifying we will get like this value. this is the Bohr magneton. Bohr magneton, 9.27 into the power of minus 24 ampere meter square. And the next I am going to start direction of the magnetic moment. How we will give the direction of magnetic moment? Direction of magnetic moment. We know magnetic moment formula from equation 3. We will get E by 2m into L. Is it right? In case of electron, right, m is equal to minus E by 2m into L, because electron charge is negative. Then magnetic moment direction is minus opposite to angular momentum. Capital M direction is opposite to the direction of L. L means what? Angular momentum. Next, in case of positive charge, means proton you take. Okay. In case of positive charge, if you take the proton or anything, okay, then m we will get as plus E by 2m. This is small m is the mass, capital M is the magnetic moment. Okay. In this case, capital M is along the direction of L. Angular momentum in which direction it is there, and magnetic moment also along the same direction. Magnetic moment is along the direction of angular momentum. For the positive charge, ML same direction. For the negative charge, ML opposite direction. Right? Okay. This is about the magnetic dipole moment of revolving electron. If you have any doubt, you can contact me in WhatsApp. Thank you for watching my lecture. Till now, if you are not subscribed my channel, subscribe and